Good day, folks. This is video tutorial number 5 for the motion design application in 3D Experience, but the playlist that deals with the dynamics problems. Uh, I would like to show you how to specify initial conditions in a very simple problem. So suppose we have a constant load applied to this block, and first I'm going to solve the problem as if the initial conditions were zero. In other words, there was no initial velocity and the block was sitting where it was. And then I'm going to come back and apply initial conditions to it. So for the sake of concreteness, let me assume that the dimensions of this block are zero point 0.1 by zero point 0.1 by zero point 0.1 meter, which means 10 centimeter on each side. And let me assume there is no gravity, so G is equal to 0. Now, if the default property of steel is used, which is in 3D experience, that volume with the density of the steel, the default density of the steel, will give you a mass of 7.77 kilogram for that block. Now, I'm going to do the simulation over 1 second, and obviously the force is constant. It's going to be 5 Newton. So the first case that I'm going to do is just apply that condition and see what is the position, the velocity, and of course the acceleration of the block. Analytically, this is a very simple problem. If you take the force, 5 Newton divided by the mass, you're going to get the acceleration. So it's going to be constant acceleration, 0.644. And then if the initial conditions are zero, velocity is obtained by integrating the acceleration, and position is obtained by integrating velocity. Now, if you do these things, you're going to get very simple functions. Velocity is going to be linear like that, and the position is going to be parabolic. So this is not rocket science, just maybe grade 12 physics, high school physics, or first year university physics. Now, these are the initial conditions. I'm going to come back and change those initial conditions to zero point 0.5 meter for position, x naught of 0.5, and v naught of 0.3. And if you repeated the same thing, you will see that again the velocity is going to be linear, different values, of course, and the position is going to be parabolic, again, different values, because initial conditions are not zero anymore. Now, I have a whole series of slides here, which I'm going to go through it quickly right now. But I'm not going to make any explaining. I'm not going to do any explaining until I do this problem for you on the screen, and then we come back and review these slides. Okay? So notice that here is the icon for initial condition. When you do that, something pops up. Uh, well, you have a choice of doing it for joints or markers, but I'll do it for markers because I don't have any joints in this problem. And uh, so if you click on this initial state solve, it will actually move to that location that you'll see, okay? The desired location. But anyway, for initial conditions, in that same dialog box that opened up on the initial condition, you can activate the position and velocity in the x direction, and then solve it. Okay. When you specify this information, when you specify these two and do initial state solve, it will actually move it to the other location. It's not going to solve the problem for you, but at least it moves it to the other position. And here is the result after I plot. And if you compare these results for the second case, they match those graphs that I gave you very close. I mean, pretty much right on the dot. Okay, we'll come back to these and talk about it later. All right, let me go ahead and start with a assembly design. There's only a single part here, and that is that block. So right click, insert 3D part. All right, so I'm going to change this thing to block and block. All right, let's go make it. Double click on it. On any plane, convenient plane, on that vertical plane, I will sketch a rectangle or square of size zero point 0.1 by zero point 0.1. Location of it is not important. And in fact, yeah, zero point 0.1. Exit. And then I'm going to pad it by zero point 0.1 because we know that the block is, each side of it is 10 centimeters. Okay, now, because later on I want to apply the force at the center of mass of this, what I'm going to do is to create a point, and the point is that the center of gravity and center of gravity of this three-dimensional object. Notice that it puts an X here. So there is a point here, that's where the load is going to be applied. That's pretty much it. So there are no joints here. So I'm going to go to and there's nothing to constrain because there's nothing to fix. So we go to motion design application, and it's going to create a mechanism. So there's really nothing in it. There is just gravity that I don't want. But for now, I'm going to leave the gravity as it is. I'm going to leave it. Later on, I'm going to come and deactivate it. But I want to show you what happens if you leave it there. And then there's a single body, the block, and there is a marker associated with it, which is right there. And there's the ground, which happens also to have the same marker because of the way we did the construction. Okay, and that's pretty much it. And of course, the point is that point that I created is down here. I'm going to collapse this. All right, now notice that there is a gravity acting downward, which later on I'm going to remove. Okay, so we go to we go to mechanism and we go find a force here, applied load, and I'm going to apply it to that point, which is easier to pick it from the tree. And it's a force, and the two options, one is fixed in the ground reference system, or follow, basically a force follower. I don't want to, just leave it the way it is, the way it is as default. And the value of it is 5 in the direction X, 5 Newton in the direction X. And we say, okay, now one weird thing is that when you look at the icon for the force, it's at a tilted angle, but it doesn't matter. That's just probably an artifact of what they did to draw to make the code. That's okay. That's in the X direction. Now, needless to say that I can run it now. Well, first of all, if I do this, if I click on this, oh, by the way, before I forget, let me go and change the time to the dynamic step. Change the time to 1 second. All right, and this is the preview. Not running it, but preview. Let's preview and see what happens. Nothing exciting. This is just going to fall because the force of 5 Newton in the X direction cannot overcome uh, the uh, the gravity. There's nothing exciting. This doesn't solve it. It just preview it. Oh, let's put it back. Okay. Now to solve it, what you're going to do is, once again, you go to Solute Simulation and run it. Again, it's going to fall. There's nothing exciting about that. Succeeded. So let's go and look at the animation. Select this, go to result. Here's the animation. And needless to say, this is going to go down because gravity is stronger than the force of 5 Newton in the other direction. Okay, so let me get back. All right, so first thing we're going to do is we're going to deactivate this gravity. You can make it 0 too, but the alternative, put the cursor there, right click, and say deactivate, deactivate, deactivate. Okay, so now let's go and run it. Go to simulation and run it. Okay, finished. And let's look at the result and animation. And needless to say, this is going to move to the left as you're anticipating. And fall, if you go through the whole 1 second, this is what's going to happen. Good. Now, let me close that. Let's go and plot a few things. Plot this, plot 2D, get 2D plot, and do the block. Show me the x position, show me the x velocity, and show me the x acceleration. Okay, these three plots, if you look at the very end, these should match what I have. Notice that the acceleration is 0.644. Velocity at the end is 0.644, and the block position is 0.322. Let's check it out. Yeah, zero point 0.6 acceleration is 0.644, velocity is 0.644, and position is 0.322. Right on the dot with these values. Okay, now what we want to do is to specify initial conditions. Now this, because we didn't specify anything, is assumed that initial velocity is 0. Okay, and initial position is wherever it was sitting, doesn't matter. Now if you look at the slides, it says when you're in mechanism, there is an icon called initial condition. Looks like that. So let's go ahead and get it. So we are in mechanism. There's the mechanism tab. You go and find initial condition right there. You click on it, this dialog box shows up. Now, what is this dialog box? It is this fellow, okay? So for the marker, you select the marker for the block. You go here. For the marker, you go and select the marker for the block. It's easy if you go to the mechanism here, it shows you all the markers. Now for the ground, the marker is right here. See that? Okay, see that? The marker is here. Where is this? This is the marker for the block. This is the marker for the block, which incidentally happens to be the marker for the ground that I didn't create. It's automatically ground is created. But anyway, select the body, this marker from the ground. Okay, it did select it. Now, there is a pull down menu here, and you select translation. And what you see there is actually this screen. Okay, okay. Actually, the next one, sorry. It's this one. Position, and go back here. Position and velocity. Position, because you want to specify the position and the velocity in the x direction, initial position and initial velocity at the x. So select this and put a value 0.5 here, 0.5, and I believe this was 0.3. Let me check. Yeah, 0.5 and 0.3. Now, okay, there is an icon here which says initial state solve. Initial state solve. This is not solving. What it does, it actually moves your part to the desired location that you specified based on this pull down menu. Remember, it says X is 0.5. So let's go back here. This is okay, just say okay. Let's find that thing that we want, which says initial state solve. Now look what happens. Let me move this thing back so that you can see what happens. If you say initial state solve, it takes a block and moves it along the x direction by 0.5 meter. So there, that is the initial condition. That is where it's going to start. And then we say, okay. Obviously, it can't show you the velocity. Okay. Now notice that this was the ground, but it got moved by 0.5 meters. So this fellow is the marker for the body. All right, that's pretty much it. So we go to simulation and run it. Okay. So what's happening is going to move from this point on. So if you go to select your results and go to animation, results, animation, it starts from that point on. Look, See that? See that? Let me put it back. And if you want to play it continuously, that's where it was originally. It got moved, and if you play it, so it's going to be not going back and forth. I'm just animating it the way. So yeah. So if you look at it like this, it's probably makes you happier. Look, starts here and moves by 1 second. It goes to that location. Now, let me stop this thing and I'll plot. Go to 2D plot. Once again, plot the from the filters, select the block, X position, and look at it. It starts at 0.5 and it goes to 1.122. 1.122. So if you look at this thing, 1.122, this is an analytical solution, okay? And if you look at the velocity, it's going to be 0.944. So let me go back here. Let's get rid of this. And you go to velocity in the x direction. It starts at 0.3 that I specified. It goes to 0.944. And of course, acceleration is going to be constant. Oh, yeah. Believe me, it took some time to get this thing sorted out. We'll do more complicated problems later on. If you can't do simple problems, this tool is totally uh, not helpful if you try to solve a problem which is heavy duty dynamics. And the purpose of my playlist is to do simple problems. Good luck.